Assistant Professor, Department of Mathematics, Kalam, District of Mark. Now, earlier we have to see that what is meant by normal subgroup and its example. Now, let us come towards it. Another definition of normal subgroup, another form. A subgroup N of G is called normal subgroup of G if every G belongs to G and for every N belongs to N, we have G and G inverse belongs to. That means for normal subgroup, we require first of all a subgroup of G and take any element in G, that is G belongs to G, and that take any element in N. This type of expression, that is G and G inverse, belongs to N. Then that N is said to be a normal subgroup of G. This for G belongs to G and N belongs to N, that is G and G inverse belongs to G and G inverse by the definition of G and G inverse. This means that definition can be written in that another form also, that N is normal subgroup of G if and only if that is G and G inverse is a subset of N. Here we have to prove that N is normal. Then we use that one of the form, that G and G inverse belongs to N, G and G inverse belongs to G and G inverse, or that G and G inverse is the subset of N, or that left coset is equal to right coset, we have seen earlier in the first part. So अगर अपने को N को नॉर्मल बताना है तो इनमें से कोई भी कंडीशन अपन इस्तेमाल कर सकते हैं. That condition treated as a definition of that normal subgroup. Now that G be a group with identity E, it is easy to verify that G and singleton E satisfy the definition of normal group. Hence, G and singleton identity are the normal subgroup of G. It does implies that every group G possesses at least two normal subgroups, G and singleton identity. That means any group अगर उसको कौन सा भी सबग्रुप रहे तो नॉर्मल सबग्रुप अगर उसको नहीं प्रेजेंट रहेगा तो एटलीस्ट वो इटसेल्फ एंड सिंगलटन आइडेंटिटी ये दो उसके नॉर्मल सबग्रुप, और अगर ये दो नॉर्मल सबग्रुप है तो ये दो नॉर्मल सबग्रुप को ही स्पेशलाइजेशन कुछ कहा जाता है. दिस टाइप ऑफ सबग्रुप इट्स कॉल्ड एज improper subgroup of G. This means that let G be a group with identity E, the normal subgroup G and singleton identity are called the improper normal subgroup of G, and other subgroup of G are called as proper normal subgroup of G. यानी इन दो को छोड़ के जो भी नॉर्मल की कंडीशन सेटिस्फाई करता है वो सारे प्रॉपर नॉर्मल सबग्रुप बन जाएंगे. दैट मीन्स a normal subgroup N of G is called a proper normal subgroup of G if and only if that N is not equal to G and N not equal to singleton identity. जो मैंने कहा कि that means what, इन दो को छोड़ के G और सिंगलटन आइडेंटिटी जो भी अदर सबग्रुप बनेंगे G के वो प्रॉपर नॉर्मल हो, और singleton, that is G itself and singleton identity, that type of subgroup are called as normal of G. Now another very main terminology, that a group having only improper normal subgroup is called a simple group. That means what, a group do not contain any proper normal subgroup, that type of group is said to be a simple group. यानी जो group को proper normal subgroup नहीं है, only having improper normal subgroup, that type of group is said to be a simple group. That example of this here, every group of order prime or prime order is simple. That is ZP, congruence model. Now next word comes that theorems that N is a normal subgroup of G if and only if G and G inverse is equal to N. For every G belongs to G, that is Gn is equal to Ng for every G belongs to G. That means what? That N is normal subgroup of G if and only this. That means first we have considered this, that N is normal. We have to prove that G and G inverse is equal to N. And now conversely, we have to assume that G and G inverse is equal to N. We have to prove that N is normal subgroup of G. Now first of all, we assume that N is normal subgroup of G, then we have to prove that this G and G inverse is equal to N. So now first we suppose that N is normal subgroup, then by definition, earlier we say that G and G inverse is the subset of N for every G belongs to G. So now for G belongs to G, and then we know that is G inverse also belongs to G because that is G is a group. So this terminology can be written as for the element in G. Now again we write for G inverse, so can be written as like this: G inverse and G inverse of inverse is containing G for every G belongs to G. So what will then happen? That is G inverse and inverse of inverse. This is nothing but itself element G. So that is G inverse and G is a subset of N for every G belongs to G by definition. Now here multiplying, post multiplying and pre-multiplying by, that is pre-multiplying by G and post multiplying by G inverse. That is pre-multiplying यानी पहले और पोस्ट मल्टीप्लाइंग यानी बाद में. इस टर्मिनोलॉजी को अपने को G को प्री से मल्टीप्लाई करना है और G इनवर्स से पोस्ट मल्टीप्लाई करना है. तो अगर मल्टीप्लाई करते हैं तो क्या मिलता है अपने को? दैट इज G इनवर्स एंड G, and that is G inverse subset of G and G inverse for every G belongs to G. If you simplify this, we get by associative property can be written as that is G inverse and G inverse, and we know that is G inverse is equal to identity element, so this is nothing but E for every G, and we know that is En is equal to again N, and that is Ne is again is equal to N, because we know the quotient property HA is equal to H. That means if and only if A belongs to H. Apply that type of results here, so we get here N is the subset of G and G inverse for every G belongs to G. This means we have G and G inverse is the subset of N. Now we have to prove that N is the subset of G and G inverse for every G belongs to G. That means both are equal. We have the first. Now conversely, here we assume that G and G inverse is equal to N. We have to prove that N is normal subgroup. That means if G and G inverse is equal to N for every G, then we know, or then we can write G and G inverse is a subset of N, and this is nothing but this is the definition of normal subgroup. Hence, N is a normal subgroup of G by definition itself. Thank you.